you try and calculate the initial pH. What's the pH at the starting point? Okay, that's the first thing that everyone does. Now, initial pH would be the pH of this butanoic acid. Now, there's only butanoic acid. It's a weak acid. For a weak acid, you have a K expression, which is that K is going to be as a K is equal to H plus 1 squared, its concentration squared, and it's going to be divided by the concentration of the acid. That is what your K is. K values are given. So your K value is given, that's given as 3.6 times 10 power minus 7. And your H plus 1 concentration, that's not known. And your acid concentration is, it is provided over here at 0.2 mole per dm cube. So the acid concentration is also known. Can anyone tell me what the H plus 1 value is, and then take the negative log and then tell me the value of pH? Has anyone calculated this?
7.14.
7.14? Okay,
Yes.
that's so. I mean that is fine. Okay, that's 7.14. Can you try and do? I'm just going to try and change the K value to -6. Did you underroot this?
No, sir.
Okay, so I think that's why you're getting a higher pH value. Okay, you have to take the underroot and then I mean, there's H plus 1 squared. So you have to take the underroot and then
So the pH is 3.57.
so the pH is coming out to be 3.57. Okay.
Yeah.
That's your starting pH, that's your initial pH. So then you try and calculate the second point, which is the equivalence point. The equivalence point is when all the acid gets neutralized, equivalence point. So this point over here, that how much butanoic acid do you have? What's volume into concentration? You'll get moles. So how many moles do you have? That would be 10 cm3 would probably be
0.002.
So you're getting 0.002 moles, volume into concentration. So volume is given, concentration is given, moles is 0.002 moles. So when will all the butanoic acid get neutralized? When you're adding NaOH from the top, that's neutralizing it. So the amount of NaOH that must be added should be 0.002 moles, right? So these are the moles that are needed from the top that need to be added into the solution so that all the butanoic acid gets completely neutralized. So at what volume would that happen? You have the moles. So remember, ignore this volume. This is the total volume that you're adding. We are looking for the volume at which equivalence would happen because only 0.002 moles are needed of NaOH for reaction. So 0.02 moles is equal to volume into concentration. So concentration is given, that's 0.2 mole per dm cube. So at what volume is neutralization happening?
0.01.
Okay, so it's happening at 0.01, which is basically 10 cm cube. So equivalence happens. We can show the working over here. You've got butanoic acid, and its moles are 0.002. Then the amount of NaOH that must be added to completely neutralize that, that's going to be 0.002 moles as well. And we figured out volume times concentration. We figured out that it's 0.2 mole per dm cube. So that means the volume needed is 10 cm cube. Okay, so from the top you need just 10 cm cube of NaOH for complete equivalence. Equivalence is the point where the pH curve would cross 7. As all the acid gets neutralized. Okay, is this clear?
Yeah.
So all your acid gets neutralized when volume is 10 cm cube. So in total, how much volume are you adding? You're adding 25 cm cube. So that means you're adding 15 cm cube in excess. So the last point that you're going to figure out is the final pH at the end. So you're adding in total. In total, what you're doing is you're adding 15 cm cube of excess NaOH. Because you're adding a total of 25. So at 10 cm cube equivalence would happen and 15 would be in excess. 15 cm cube of excess NaOH has been added. I mean, that would be the one that would be present in the reaction mixture at the end. So how many moles is that? That's the concentration I think was given. That was over here. It was 0.2 mole per dm cube. So that was provided. So it's going to be 0.2 multiplied by concentration times volume. That's 15 cm cube of extra NaOH. So that should be divided by 1000. So what do we get? Is it 003 moles? Is this correct or wrong?
Yeah, it's correct.
So you've added 0.003 moles. All the butanoic acid has reacted. You've added in excess an extra 0.003 moles into the mixture. So that's the only thing that's left in the mixture. And you're supposed to find concentration. Now these moles, the two solutions at the end would mix up. So 25 cm cube of NaOH, and there's going to be 10 cm cube of butanoic acid. They would all mix up. So the new volume is going to be 35 cm cube. So the concentration of these moles would be moles divided by volume. The new volume is 0.035 dm cube, which is 0.035 dm cube, which is 35 cm cube. Because the two solutions have mixed up. So what's the new concentration of NaOH in the flask?
0.085. You can
Take a mole per dm cube, and what you also have is you can find you can now find pOH. So what is pOH? And then eventually you can find pH. I mean, these are OH concentrations. You can find the OH concentration, and you take the negative log of this and then subtract from 14.
.06.
So this is 1.06. So this would be 13.94. 12.94.
12.9. Yeah.
So that's going to be 12.94. So pretty much you've figured out all the points. So y-axis, z-axis, this is the volume of NaOH that you're adding from the top, which is a total volume of 25 cm cube. Okay, so a total volume of 25 cm cube is being added. This side, this is your pH side. अच्छा, और फिर starting pH was, I think we did calculate the starting pH, it was 3.57. That was when you had acid in this. So 3.57, you start off with 3.57. Equivalence happens at 10 cm cube. And your final pH over here is around 13, 12.94. So it goes up till this point. So this is the part where at equivalence the pH curve would almost be vertical. So it's going to, there would hardly be any change. Most of the pH changes around the equivalence point. Okay, is this clear?
Yes, sir.
Yes.
So that's all about pH curves. About pH curves, there's a point known as the half equivalence point, which we did discuss earlier. Half equivalence point is, I mean, it's going to be this one. It's 5 cm cube of NaOH. That's the half equivalence point. Okay, so there's a thing called the half equivalence point. So what happens at half equivalence point is that your pH value and your pKa value would be exactly the same. So if you want to calculate Ka value, you just measure the pH, or you just, if you're given a graph and you're looking for the pK value or the Ka value, look at the half equivalence point. Whatever the pH at that point, that's going to be your pK. The reason is that at half equivalence point, like 10 cm cube of NaOH would completely neutralize the weak acid. 5 cm cube of NaOH would neutralize half of the weak acid. So at that point, the concentration of your conjugate base into H plus 1 divided by the acid concentration. When half of the acid is neutralized, that means, like if you have 10 moles of ethanoic acid or any acid, if half of them get neutralized, they're going to form, 5 of them would be left behind and 5 of them would form the salt. So the concentration of these two ions would be exactly the same. Or these two molecules, they would be exactly the same. So this happens at the half equivalence point. The concentrations, they become exactly the same, which is why your K expression is now just basically equal to your H plus 1 concentration. So if you just measure the pH at the half equivalence point, that's going to be equal to pKa. The negative log of H plus 1 would be equal to the negative log of Ka, because these two are going to get cancelled out because they would have exactly the same moles. When half of the weak acid is neutralized, the rest of the half turns into the salt, so they have exactly the same number of moles. Is this part clear?
Yes, sir.
Yes, sir.
ठीक है, सारों को clear है? Lubena, is this clear?
Yes.
अच्छा, so pH curves, you can find Ka value as well using these pH curves, and so we're going to try and do the opposite now, which would be slightly different. Normally these titrations they don't come in your exams because the question kind of gets slightly more complicated, so it's slightly tougher for the students, but it can obviously appear in your exams. Now I've got the same butanoic acid, except for the fact that in the flask we've got NaOH, so we've turned things upside down. So there's 30 cm cube of 0.1 mole per dm cube NaOH in the flask. And from the top, we are adding 50 cm cube of 0.1 mole per dm cube of butanoic acid. So it's just the same thing, except everything is happening in reverse. We'll quickly try and do this. Initial pH, number 1. Initial pH में कि it's a strong base. The OH ion concentration that's already known, that's 0.1 mole per dm cube. So you know this value already. It's a strong base, so that means all of it is going to ionize and all of it would turn into OH ions. You take the negative log of this, that would come out to be, I think, 1. So that's your pOH. Your pH would actually come out to be equal to 13. Okay, is this clear? You clear?
Yeah.
Yes, sir.
अच्छा फिर उस पे आ जाओ कि what's your अच्छा उस पे आ जाओ what's your equivalence point? Now it's fairly obvious that since I'm using the same concentration, then 30, because it's 1:1, 30 would react with 30. We don't need to even do calculation. So the volume that is needed, volume of KOH at equivalence, or sorry, volume of ethanoic acid that must be added, is going to be 30 cm cube. Then all the NOH would have reacted with it. Because it's 1:1, the concentrations are the same, so 30 cm cube would react with exactly 30 cm cube. So that's your equivalence point. ठीक है, ये भी clear है? Yes or no? Is this clear?
Yeah.
Yes.
And then finally, the last part, that's complicated. That's the final pH at the end. ठीक है, this last part is complicated. Okay, how much excess is being added? That's 20 cm cube is in excess. Because you just needed 30, you didn't need 50. So that means there's 20 cm cube of so there's 20 cm cube of excess ethanoic acid, butanoic acid. So how many moles is that? That's 20 into 0.1 mole per dm cube. You know the concentration, so it's 20 times 0.1 divided by 1000. So
0.002.
so that is 0.002 moles. अच्छा, अब ये कि you found the excess. I mean, that's at the end of the day, this is the excess butanoic acid that would be present in the flask over here. What else would be present? What else would be present is that the butanoic acid, the remaining butanoic acid, I mean, what happened to the previous 30 cm cube? You added 30 cm cube of 0.1, that's 0.003 moles. Out of the 50, 20 is in excess, 30 has reacted. So this is what's happening to the 30 cm cube that reacts. It gets used up. But what has happened to it? It has reacted with an NaOH and it has ended up forming a salt. And water. So the 30 cm cube that had reacted previously with the 30 cm cube of NaOH, that's 0.003 moles, would end up producing 0.003 moles of this particular salt. So your flask over here, not only does it contains the excess butanoic acid. So your flask over here contains the excess butanoic acid. But it also contains the salt of the same butanoic acid, because the previous 30 cm cube that had reacted out of the 50 cm cube has ended up forming the salt. Is this clear?
Yeah.
Yes, sir.
तो इसका मतलब है कि if you have in a solution, you have both things. You have the weak acid plus you have its conjugate base as well. This is 0.003 moles. And this over here is 0.002 moles. So if both things are present, that means it's a buffer solution. And to calculate the pH, you would have to use the formula of the buffer solution, which is going to be, so that one is going to be, I mean, we know the K, which is which was given in the previous question as well. For butanoic acid, I think it was, what was the K that we were taking? 3.6 into 10 to the minus 6. So we're using 3.6 times 10 to the minus 6. That's equal to conjugate base concentration 0.003 moles into H plus 1 concentration, that's product, divided by the acid concentration, which is 0.002 moles. I mean, you can use concentration instead of moles, because if you divide by volume, they both would cancel out. So no need to actually divide by volume to find concentration. So how much H plus 1 are we getting? So what's H plus 1? What's the pH?
H plus 1 concentration is 2.4 multiplied by 10 to the power of negative 6, and pH is 5.619.
5.619. So ठीक है, 5.619. अच्छा, but anyways, just make sure that you understand this, that in this case, at the end of the day, okay, let me highlight this, that when butanoic acid was reacting with NOH, it was forming a salt of butanoic acid. So the solution mixture had a salt of butanoic acid. Up till the equivalence point, a salt was formed. And then the reaction stopped, and you started adding 20 cm³ of excess butanoic acid, which meant that now you've started adding the acid. I mean, previously you were constantly forming a salt when the reaction was taking place, so the salt is already there now. But now you've started adding the excess butanoic acid, so now you have the acid as well. So whenever you have a conjugate base plus its weak acid, it's going to form a buffer. TK, is this question clear?
Yes, sir.
Yeah.
अच्छा ठीक है, just one second. अच्छा अब ये कि we're going to do past paper questions, ठीक है, जिसके अंदर we'll study more pH curves. The next thing I wanted to talk about was were two things. That's part of organic, but since when we move to past papers, we're done with the whole pH thing basically. But when we move to past papers, most of the questions are tied up with organic. So which is why we should, I think, learn about the chemistry of weak acids. Why are certain acids weak? Why are certain acids stronger? So chemistry of weak acids plus the chemistry of weak bases as well. So this is part of organic, but since most questions are linked with this thing, okay, so I think we should study this together because all the questions would be talking about both things. इसमें बस just a basic idea that in organic chemistry, most of the weak acids are molecules. There are three types of things that are acidic in organic chemistry. One is alcohols. It's basically anything that has OH. Okay, anything that has OH, that is kind of could be considered a weak acid. So, for example, you've got an alcohol. So the ONH is capable of ionizing, and it would produce two ions. One is going to be RO minus 1, and the H plus 1 would get knocked out. So that's one. Then you've got your carboxylic acids. Pretty much the same thing going on. It's the only difference is it's now RC, double bond O, and OH. You still have have the same OH group. So in this case, exactly same thing happens. The OH at the end, it ionizes and ends up producing O minus 1 ion and an H plus 1. And then you have another weak acid which is known as phenols, which you haven't studied yet. Phenols are, I'm going to discuss the benzene structure in a. Phenols have benzene in them, and they also have an OH group. All three are completely different organic compounds. Now, since it has benzene, so I've got the O would break off, and H plus O ions are going to be produced. So I've got 3 types of weak acids: carboxylic acids, phenols, and alcohols. All 3 are going to ionize and release H plus 1. And every time it's going to be the OH, the one that you see over here. That's the one that's going to be released. The strongest, I mean, and this is a relative comparison. All of them are weak acid. Carboxylic acids are considered to be the strongest out of the 3, and alcohols are considered to be the weakest. And phenols are somewhat an intermediate. They're not strong, not weak. So we're going to discuss why certain acids are stronger and why others are weaker. Okay, why? Because they all have OH groups. All of them, they have this H plus 1 breaking off. But relatively speaking, why is carboxylic acid? Why is it easier for it to do that? And why is it so hard for alcohols to do that? Why are they the weakest? Islam. ठीक है, ये हम ना फिर कल नेक्स्ट क्लास में ना डिस्कस करेंगे, ठीक है?
Okay.
चले, ठीक है. Okay, take care. Lafez. Assalamu alaikum.